Hello. This time I'm going to explain section 4.8, which is about the antiderivatives. Okay, there are 25 programs, mostly just simple computations. So start explaining from question number 1. Find an antiderivative for each function when c equals 0. Okay, so to find antiderivative of 10x to the power of 9, okay, using a power rule in opposite reversed way. So it's going to be x to the 10th. Okay, the power is raised by 1. And mentally try to differentiate x to the power of 10 to get 10x to the 9th. So this is the antiderivative of 10x to the power of 9th. Okay, so the rule is x to the n is x to the n plus 1 and 1 over n plus 1 in front plus c. So x to the power of 5, it's going to be x to 6 and divided by 6. When you have a difference or sum of the terms, just like in the differentiation, you can take antiderivative of each terms and you take the sum. So this is going to be x a third, 1/3, minus x squared, which gives you 2x, minus 24x. Okay. Okay, now second problem is when you have a negative exponent, but you still can use the same formula, even you have a negative number for n. So for example, -6x to the power of -7. So raise this one by 1, you're gonna get x to -6. And do some mental computation. This gives you this one after you take a derivatives. So this is the answer. This is antiderivative. So this is gonna be raise 1 and divided by -6. Okay. And again, when you have a sum or difference of the functions, you can take antiderivative of each term and you take a sum. So the first term, antiderivative is -1/6 x to the power of -6 plus this is going to be x cubed plus this is going to be 4x. Generally, there's plus c, but this problem is finding antiderivative with c is equal to 0. So we are going to ignore this part. Okay, now you have fractional power, but you still can use the same rule. Okay, so even when you have a fraction here, you still can use the same rule. So adding 1, so -1/9 plus 1 is going to be 8/9. So it's going to be x to 8/9. When you differentiate this, you're going to get 8/9, but you have 2/9. So you want to divide it by 4 to gives you 2/9. Okay, so this one is going to be dx. It's going to be x 7/9. That gives you 7/9. So I have to divide it by 7. Okay. Okay, so this is adding 1 to the power, you're going to get -1/9. And when you differentiate this, you're going to get -1/9 in front. So it's already in perfect form. So that's the answer. Okay, now we are moving on to trig functions. Here's some note for you. This is something covered in the lecture note. So up to the problem 3, we are just using the first one here. We are just using this formula. Now we are going to sines and cosines. So the antiderivative of sine is going to be negative cosine, and antiderivative of cosine going to be positive sine. Okay. So let's see. Negative 11 sine of 11x. So when you take antiderivative of sine, it's going to be negative cosine. But think about just the cosine. So when you differentiate cosine of 11x, you're going to get the negative sign and you have 11 came out. So this gives you this. So that's going to be the antiderivative. Antiderivative of sine x times 3, that's going to be cosine x. Okay, sine become cosine. But when you differentiate cosine, actually you're going to get negative. So you have to multiply it by negative 3 to make sure that the number here matches. Okay, now this is like you have two terms, but again, it's the same thing. You just integrate each and just take a difference. So sine become cosine, inside angle doesn't change. And when you differentiate this, you want to get negative 11. So you want to divide it by negative 11. Same thing here. Antiderivative of sine 3x should be something like cosine 3x. But when you differentiate this, you're going to get negative 3 out. So you should just have plus here because number is already here. Okay. And plus c, but the c is 0 in this problem. Okay. Okay, now looks like a formidable one. So there's two formulas we want to know, which is derivative of tangent is secant square, and the derivative of cotangent is equal to cosecant square, but with negative in front. Okay, so that's the key idea. So first one, the antiderivative of cosecant square is basically cotangent, but you have to deal with negatives here. Now, how about this one when you have 7 in front? The idea is similar. You just take a cotangent, inside angle doesn't change. But when you differentiate this, you want to get negative 1 over 7 in front. Negative 1 over 7 in front. So I had to divide it by negative. I had to multiply by 7, basically. So it's going to become negative 6 here. And the third one. Okay, so again, it's going to be cotangent of the same angle inside. And when you differentiate this, the sign becomes negative, so that's already good. And 7 over 6 came out, so I had to multiply it by its reciprocal. Okay, now find the indefinite integral. So now we have to, we cannot forget about the integral constant c, okay? So integration of 6x plus 8. So first of all, find the integral in each term. You want to get 3x squared plus 8x, and you add c. Okay, next one. 2x cubed minus 3x plus 5. So I just integrate each term using the power rule. So first one going to be x to the fourth. That gives you 4 in front. So I had to divide it by 4 to get 1/2. Next one going to be x squared. But 2 came down, so I had to divide it by 2 to make it this. And you have 5x. And don't forget about c. Okay, next one. The original expression is in fraction, but it is restated as x to the negative fourth minus x to the fourth minus just a number. So this one, using the power rule, raise the power by 1 and divide it by that number. Do the same thing here. So it's going to be x to the fifth, but divided by 5, you're going to get this. And the number, when you integrate the number, you just multiply it by x, and you don't forget about putting c. Okay. Now the radical expression x to the power of nth root of x is the same thing as x to the power of 1 over n. So this expression is the same thing as x to the 1 over 9 plus x to the 1 over 10. So again, using the power rule, raise the power by 1 and multiply it by its reciprocal. Do the same thing here, raise the power by 1 and multiply it by its reciprocal and add c. Okay, now this is not so easy one. When you have a product of two functions, in general, it's very difficult to integrate, or maybe impossible. But in this case, you can just expand it to make the product into sum. Then you might be able to integrate. So in fact, for this one, after you expand the expression, you want to get 45x minus 9 times x to the power of negative 8. So here it is x times x to the negative 9, which is same thing as x to the 1 times x to the 9, negative 9, which is using the exponential rule, it's going to be 1 minus 9, which is negative 8. So it's just the exponential rule. Now integrate each term using a power rule. So x become x squared over 2. And this is going to be adding 1, so it's going to be negative 9 and divided by negative 7 and divided by negative 7. So it's going to become positive 9 over 7. Okay, always check to see that this is, when you differentiate this, go back to this. Okay, and also don't forget to add the integral constant. Okay, now again, the trig functions. So the integral of cosine is sine. The inner function, inner angle doesn't change, and derivative of sine becomes just cosine. So just multiply by 2 at the end. Next one, number 10. So the inside is same thing as 1 over 5 times theta. So again, this is cosine of some linear function. So just integrate it to get sine of the same angle. But when you differentiate this one, you become positive 1 over 5 theta times 1 over 5. So it's going to be divided by 5. So I had to multiply it by its reciprocal. So I just multiplied by 5 at the beginning to make it 35. Now this should give you 7. And don't forget to add c. Okay, next one. Negative 9 times secant square x. Okay, so what's the antiderivative of secant square? Well, that is tangent. So it's going to be tangent. And when you differentiate this one, you want to get this. So just multiply it by negative 9 and add c. Okay, something we haven't seen yet. So cosecant times cotangent. Well, that's actually here, the purple one here. So the derivative of secant will be secant tangent. And its pair, the conjugate pair is the cosecant. The derivative of cosecant is going to be negative cosecant cotangent. So just adding just co, okay? But the sign flips. So it's kind of similar with these pink ones and purple ones. Memorize the top one, the parent one, and then the core version, the core function version is like just you changing the sign to negatives. Okay, so since derivative of secant is sec tangent, and the derivative of cosecant is cosecant cotangent, but you have to have negative here. Okay, so the integral of cosecant cotangent divided by 2 is from here, it's going to be just a negative cosecant theta. And you just multiply it by 1/2. Okay. Now next one. -2 minus 2 tangent square theta d theta. Well, this one, we didn't see any tangent square here. We don't see any tangent square in this left side of the table, but we know that tangent 1 plus tangent square is equal to secant square. And that's how we're gonna take an integral of this, because we know how to take an integral of this one, okay? So start from the beginning. We write the expression, but first of all, factor out -2, and how convenient you wanna get the secant square here, okay? And antiderivative of secant square is tangent, okay? Similarly, if you see cotangent square, then try to use 1 plus cotangent square equal to cosecant square. Rewrite this one into this, then you can take an integral. Okay, now we have something new. Number 16. 7/7x plus 5 dx. Now the basic one that we will need to use now is natural log, which is this one, the second one here. Okay, second one. So integral antiderivative of 1/x is going to be natural log of absolute value of x. Okay. So now instead of x, you have 7x plus 5. And remember that the derivative of natural log of u is equal to u on the bottom and u dash on the top. Okay, so this one actually satisfies that kind of form. So it's going to be something like ln of 7x plus 5 absolute value. And the derivative of the inside is going to be 7. So that's going to be the antiderivative. Now I just need to add c. Okay. Okay, this is the even harder one. Now you come with inverse trig functions. So this is like a verify why this is true. So verify. So I just need to show the derivative of something. Okay, something. but derivative is something that we can use this one. So we start with some function f dash and g dash, okay, using a chain rule. So first of all, we have a function f of x is equal to cotangent of x times 2 over a. Let's consider this function. So forget about the inner function. And the inside function, let's say inside function is 2x over a. Now, the composition of these two functions is going to give us 2 over a cotangent inverse of gx, which is 2x over a. We are trying to use the chain rule. So derivative of this one is f dash of gx times g dash of x. So I need to know what is f dash is. And f dash of x is, if you remember the formula correctly, this is just a number. And the derivative of the inverse cotangent is 1 plus x squared on the bottom, and top gonna be 1 times negative 1. So f dash of gx will be this part gonna become this. So that's the only difference. So it's gonna be negative 1 over 1 plus 2x over a square. Now we are going to multiply it by this one, and this one is obvious. This is 2 over a times x, so that's derivative is gonna be 2 over a. Okay, so that's what is covered here. Should be which one here? Well, which one? The last one. I don't know which one is which. Okay, so let's start from the beginning. So what function should be differentiated? This one to check right-hand side, okay? And using a chain rule, how should I set f and g? So f is outer function and g is inner function like this. And the derivative of those is gonna be this and this as shown here and here. So the derivative of applying a chain rule, so I just need to multiply this result, it's f dash of gx times g dash of x. So f dash of gx times g dash of x is 2 over a minus 1 plus 2x over a squared times 2 over a. Okay. Do I need to simplify it? Yes, I had to simplify it to make it to the left-hand side. So I had to simplify this one. I don't like this fraction much. So first of all, 2 times 2 is 4 times negative 1, 1. A times a is a squared. And we left with this. Multiply top and bottom by a squared. Okay, a squared to reduce the fraction here. So I multiply by this. It's already here, but well, in general steps, it's gonna be a squared here. And when you expand this one, you're gonna get a squared plus 4x squared. Now reduce this part, you're gonna get negative 4 over a squared plus 4x squared. So that is equal to the inside of the integral sign in the left side of the equation. So now we showed the derivative of the right side becomes left side expression. So that's finished the verification. Okay, so this is just like shows up it's true or false. And well, if you remember the chain rule, it's simple to check. Okay. Well, what is the derivative of this one? Okay. What is derivative of this one? That's gonna be using a power rule. It's gonna be 3 times 4x plus 7 to the 2 times derivative of the inside, which is 4. Okay, so that's all you need to check and show that whether it becomes left side without integral sign. Okay. Okay, number 19. Graph the function that shows the solution of the initial value problem. So you have a y dash is equal to 8x. And we know that when x is equal to 1, y is equal to 8. So we have given the initial condition that the graph has to go once 8. Now, first of all, let's find the antiderivative of this one. So that's going to be y is equal to 4x squared plus some constant. Okay. And when x is equal to 1, y is equal to 8. So since this one has to go through 1, 8, c is equal to 4. Plugging into here, you want to get y is equal to 4x squared plus 4. That's a parabola. That's a parabola like this way, with the y-intercept is 4. The vertex is 0, 4. So the graph looks like this, and it goes through 1, 8. So the best choice is choice A. Okay. Now, which of the following is correct reason for the answer in the previous step? Well, because 1, 8 is on the line and on the graph is same thing in all 3 choices. Straight line, that cannot be, so it should be parabola. And we know that this graph doesn't go through 0, 0. When x is 0, y is not 0. So the better explanation is it's a parabola not passing through the origin. Okay. Okay, another initial value problem. No graphs. So number 20. Y dash is equal to 6x minus 5 with the initial condition of when x is equal to 2, y is equal to 0. So y is equal to the integral of 6x minus 5, which will be 3x squared minus 5x plus c. But since we know that when x is 2, this becomes 0. So plugging 2 here, you want to get 12 minus 10 plus c is equal to 0. Solving for c, it's going to be negative 2. So using this and this, you get y is equal to 3x squared minus 5x minus 2. Okay, again, another initial value problem with just trig function involved. So s dash is equal to 6 plus 5 cosine t with initial condition of when t is equal to 0, s is equal to 7. Okay, now let's integrate 6 plus 5 cosine t with respect to t. That's going to become 6t plus sine t times 5 plus constant. Okay, so that's 1. And since when t is equal to 0, sine 0 is 0, so that becomes 7. So c must be 7. So from 1, 2, you can get s is equal to 60 plus 5 sine t plus 7. Okay, two-step problems. Now we know that this is y dash dash. So we know that y dash dash is equal to 10 minus 18x. And the y dash of 0 is equal to 4. That's the initial condition. And another condition, y of 0 is equal to 7. Okay, so we need to find the antiderivative of this one, which is this, and antiderivative of this one to get this. So it's a two-step problem. So let's find y dash. So y dash is going to be integral of 10 minus 18x dx. And that's going to be 10x minus 9x squared plus c. Okay, now we know that the y dash of 0 is equal to 4. So c must be 4. So from those two, y dash is equal to 10x minus 9x squared plus 4. Now we are going to use this and this to find y. It's another antiderivative problem with initial condition. So integrated, you're gonna get 5x squared minus 3x cubed plus 4x plus c. And when x is equal to 0, y is equal to 7. So we know that 0 plus 0 plus 0 plus c is 7. So it's obvious that the c is equal to 7. Okay. Now, well, that's the answer. Well, this is not the best answer. Hopefully, you can rewrite the expression in descending order of degree like this. Okay. Now, next question. Find the curve in the xy plane that passed through the point 94 and whose slope at each point is 3 square root of x. So we know that the graph goes through 94, and we don't know what the graph looks like, but the graph's slope is always 3 square root of x for each x. So that indicates the slope means the derivative. Derivative is 3 times square root of x for every x in the domain. And we know that the graph goes through 9, 4. So when x is equal to 9, the y value is equal to 4. Okay, so this is the initial value. Value is given. So again, it's the same kind of question once you set up the equation like this. Okay, so y is equal to the integral of 3 times x 1/2 dx, which is same thing as x is 3 over 2. You raise the power by 1, and you have to divide it by, well, multiply it by 2/3 to get 2, and plus c. So that's 1. And because f of y of 9 is equal to 4, it's going to be 9 times 9 to the power of 3 over 2 plus c is equal to 4. So what is this? So 9 to the power of 3 over 2 is same thing as 3 squared to the 3/2, which is same thing as 3 cubed, which is 27. So this is going to be 27 times 2, which is 54. So c is equal to negative 50. Therefore, the y is equal to 2 times x to the power of 3 over 2 minus 50. Okay, now next one is again the initial value condition problem. Well, we know that y dash is given like this. So you just need to integrate it, and you're going to get some integral constant c. And we know that that goes through 1, 1. So number 24 is the y dash is equal to 1 minus 7 over 3x 4/3 with the initial condition of when x is equal to 1, y is equal to 1. Okay. So once you set up this one, you can find y quickly by taking the integral, which is x minus x to the 7/3 raised the power by 1 and plus c. And since y of 1 is equal to 1 minus 1 plus c, that's equal to c, so c must be 1. Okay. From these two informations, you can find the answer as in the left side here. Okay. Okay, final question. Number 25. A driver driving along a highway at a steady 65 miles per hour sees an accident ahead and slams on the brakes. What constant deceleration is required to stop the car in 288 feet? So car is driving like this way, and you see the accident here. So he is going to brake to try to stop, before driving some amount of distance, which seems to be 288 feet. Okay, to find out, carry out the following steps. Okay, so here is a given program, initial value program. So let's say the position function is s, and the position function is derived, differentiated twice. The s dash dash is the acceleration. Remember, when this is a position, then this is a velocity, and the second order derivative is acceleration. Okay, so the acceleration of the car, which is a braking, is constant, negative k. Okay, and ds dt, which is s dash of t, is equal to 96 when t is equal to 0. Okay, and the position at 0 is equal to 0. So you are given with some function with two initial conditions. Okay, so now let's find the functions first. So let's integrate this one. You want to get negative kt plus some constant. And we know that when t is equal to 0, this becomes 96. When t is equal to 0, this is 96. So it's obvious that this is going to be 96. Okay, now the position is the integral of this one. So it's going to be t squared divided by 2 plus 96t plus the initial position. And when t is equal to 0, st equal to 0, so this is going to be 0. Okay, so that's going to be 0. So the first answer first question, let's find the position vector, a position function. So that is this. Number 2, find the value of t that makes the speed is 0. So we want to find the time it stops the car. So the speed becomes 0 at what time? The speed is negative kt plus 96, and that's equal to 0. Solving for t, solving this linear equation, t is equal to 96 over k. Okay, so that's the time that the car stops. Now, number 3, find the value of k that makes s is equal to 288. Okay, so we want to find the value of k so that at the time the speed becomes 0, the position is 288. Okay, so plug in 96 over k into the position function. So it's going to be negative k over 2 times 96 over k squared plus 96 times 96 over k. And that is equal to 288. Okay. Now we are going to solve for k. No. We are going to solve for t. Not t. K. We are going to solve for k. Yeah. Okay, so first of all, this is going to be 96 squared over k times 2 negative. This one going to be 96 squared over k, and that is equal to 288. Multiply both sides of the equation by 2k, let's say. Let's multiply both sides by 2k to eliminate fractions. So it's going to become negative 96 squared plus 2 times 96 squared is equal to 2 times 288 times k. So this is like you have like 2 apples minus 1 apple. So it's going to be just 1 apple. So 96 squared is equal to 2 times 288 times k. So solving this linear equation, divide both sides of the expression by 2 times 288, and you just reduce these fractions. But 288 is same thing as 12 squared times 2. So that might makes it easier to see. And 96 divided by 12 is going to be 8. So this is going to be 8. And this is going to be 8. So it's going to be 16. So k is going to be 16. So it's a short section. Well, other than like understanding how to solve the initial value problems, just be comfortable with finding the antiderivative of these basic functions, okay? Because for the integrations, we will have to learn many techniques to solve a variety of functions in the variety of functions to integrate in the future. So please getting comfortable with these basic functions as soon as possible. Okay, so that's it for today.